Hello, my name is Gerard Alvarez and my mate León. We are two students of engineering of telecommunications and we are going to explain how we do our project of the roulette. First of all, me I'm going to explain our story of how we decide to do this roulette, and then my mate will explain how the roulette works. First of all start when we are working for the street of Barcelona and we see a casino. And we decide to enter in to see what is going on. First of all, and what we caught our attention is that most of the people are playing the roulette, one of the most popular games in the casinos. So we decide to know how the roulette works and why the people play a lot this game. So what we are going to do now, and that will explain my mate Eric, is how we can do a roulette, but instead of do it like a classic roulette with a ball, we are going digital with using LED and some chips.
My name is León and I'm explaining the function of the invent that is the roulette digital. We can see that this roulette is different of one classic roulette. Why? We can see that the roulette don't have the white ball, and we change the white ball for one system of select generator and counting. This function is when we click on the button, the select generator start, and the counting is turning the roulette, and depending of the number that we get, the LED turn on and the all other LEDs turn off. The function of this roulette is thanks for one chip that we configure. The chip is the chip Max 10, and we configure in one tool that this name is Quartus Prime, that here we execute the commands necessary for create this roulette in form digital.
Now we are going to see what components we have our roulette. First of all, the most important, the plate with the numbers, then the LEDs, that it's very important that they are in the sequence, like one red, one green, one red, one green. It's important that don't repeat the colors, like two greens and one red. And then the yellow LED, that is very important because it's the LED for the number 0, that is the special number, that in the classic roulette we see like the color green, but in this case we choose the yellow. Then we have the resistor, that we have the draw in the plate to put each one in his side. Then we have this to put the batteries, that is the most important thing of the circuit, because if we don't put the batteries, the circuit don't work. Then we have the button to start the process and start the select generator that explained my mate before. Then we have a condensator and the quantifiers. And basically, that's all of our components that we use in our project to do this roulette.
Hello, now we are going to run the simulation in Quartus Prime. From problems with the company, we need to do this session online. So we start explaining the files of the Quartus Prime. First of all, we can see the file of the roulette, the most important one, and we can see the basic components of the roulette. The controller, the counter BCD mod 37, the decoder BCD binary, and the CLK generator. And now my mate will explain the other files.
Hello, I am Eric, and I'm explaining the files of play in Quartus Prime. and we can see the Celica generator with the inputs and the outputs. In our case, the Celica is 44 hertz, and we can see the counter BCD mode 37 with the inputs and the outputs. We can see the vectors, and the equation format this counter. We can see the counter mode 16. This file is download of Dixis, and we don't modify this. And the decoder binary, that this is important for our project, that we convert the number in binary. We can see the all of case. We can see the controller, that this function is run if we pulls the button, run the roulette, and we can see the code, the frequency divisor, that in our case is this frequency divisor, and the toggle flip-flop, that is a synchronous flip-flop of 1 bit. And now my mate explained in Quartus Prime the state diagram.
Okay, here we can see the state diagram. We can see the CD start, and we can go to the starter. If we have a 0, the starter continue in the starter, and if we have a 1, the circuit start and start running. So in the running, if we have a 0, we continue running, but if we have a 1, we go to the standby button. And here the same, if we have a 0, we stay in the standby, and we have a 1, we go to the running another time. And we repeat this process all the time until we have the only one LED, that is the LED that stay on. And now my mate will finish the presentation explaining the RTL RTL schematic.
Now I'm explaining the RTL viewer. Here we can see the 3 inputs, the inputs of the button of play. Here we can see the Celica and the CD, and we have 4 chips, that inside in this chip is another chips or circuits. In Celica generator we can see another 2 chips, the frequency divisor and the target flip-flop. In the controller we can see one circuit. In counter BCD mode 37 we can see another 2 chips, that is counter mode 16, and the chip 4 is the decoder BCD binary, that we have 6 MOOCs, and the outputs is 37 outputs, that go the number 0 from the number 36. And that is all. Thanks for listening. But before of end, I want to thank the sponsor, that is Clideo, a sponsor of this video.